Hi everyone, welcome back to my channel Vertex MrRoy. As today we are doing exercise 15.1 from the Atmas book. So I would like to say please watch my previous video that how we can do the basic differentiation and how we can use the formula of differentiation. But before starting this exercise, I would like to give some review of the previous topic that what is differentiation. Like in differentiation normally what we have what are the formulas and how we have to apply. Differentiation basically is d upon dx we write, and I am writing just one example here. Like when you have x power 5, what is the differentiation? Even if you have 2x power 5, what is the differentiation? Okay, when you have differentiation of 5x, or when you have the differentiation of only constant term, or when you have the differentiation of under root. I'm just giving some special like here terms I'm using here. This is only 5x, this is only 3, and here I'm writing suppose under root x, and then I'm writing 1 with negative power. Okay, x power is minus x 3x power is minus 2. Okay, when you do this like basic differentiation, you will be able to do this question. And please, this exercise is important because we are doing each and every step to understand the differentiation, because after this exercise 15.1, question number 1 till 4, you will be able to do the other questions, the difficult questions, more easily. What we do in the differentiation, 5 into multiply is what? 10, and power will become 1 minus. So this will become 4. This 5x is only 5. This x, the 3 is 0. It means the constant term differentiation is always 0. Under root differentiation I have done in my previous video. You can watch. This the direct answer we can write 1 upon 2 under root x. Whenever we have under root, please, under root x, the differentiation is direct. You have to write 1 upon 2 under root x. You have to learn by heart. This minus 2 and minus 3 is minus 6 is plus 6, and power minus 2 and minus 1 is minus 3. So this is the way you should remember these steps, these rules to understand this question. Okay, I'm doing A part in detail, then other parts will be a little bit faster. Like A part, when I write differentiation, I will write the differentiation with each and every term. Like first I'm writing this 4x and minus 1. It means the differentiation is applied with each and every number. So I can write d upon dx with 3x squared, d upon dx with 4x, and d upon dx with 1. So actually, just to explain this in this exercise 15.1, first question, I'm doing all the questions step by step. 3 times 2 is 6, and x power will become 2 minus 1 is only 1. I don't need to write 1, plus 4x differentiation, like 5x differentiation is 5, so 4x differentiation is only 4, and 1 differentiation is 0, so I don't need to write. This is the answer. Can you do like C part in like little bit fast if I try? What is the differentiation of, like, I have to write like here d upon dx. Okay, 3 power will multiply with the constant term coefficient. 3 times 2 is 6x, and power will become 2. 5 times 2 is 10x, and this 4x will become minus 4, and that's we have done it. This part I have to do what? First of all, I will move this denominator up to make it negative, because I have to shift all the variables up. This, now we can apply the differentiation. When you apply the differentiation, what are the results? 9 times 2 is 18. 18 power is 1. We don't need to write 1 here. Minus this minus and this minus multiplied. 3 times 2 is 6. Positive 6, and x power minus 2 minus 1 is minus 3. Or you can write your answer like this. Positive if it is up to you. Okay, C part we have done. Moving to G part. Sorry, this was E part, not C. G, like 3a. Here is already given in the question, like where a and b are the constant term. When 3 is constant, a is constant, it means the whole term is constant. The result will be what? The result will be 0. The differentiation of constant term is always 0. And the differentiation of b x squared, 2 power will become the coefficient, multiply with 2b. So that's your result. We don't need this 0 now. 2bx. This question, I part, when I do here, the root is also there, right? Under root. So 3x, when I write here the question, 3x plus 2 under root x minus 3. 3x differentiation is only 3 plus 2 is there. The differentiation of under root x is fixed. I told you is under root x is 1 upon 2 under root x. So I will write 2 under root x will become 2 upon 2 under root x. This 2 will not be changed. Anything will be happen on this and this will become 0. This 2 and 2 cancel out. So the final answer is 3 plus 1 upon under root x, and this is the way. Okay. Moving to part K. In part K, we have to do the differentiation in such a way that power. Apply the formula, very simple. This 5 upon 2. 2 multiplied by 5 upon 2. I'm applying the differentiation directly. 5 upon 2 and x power will become 5 upon 2 minus 1. I applied here. Then here minus 4 multiplied by 3 upon 2 and x power will become 3 upon 2 minus 1, and the differentiation of 6x is only minus 6. Yes, and differentiation of 8 is 0. So when we simplify this, is coming 2 and 2 cancel out. So 5x, 5 upon 2 minus 1 is 3 upon 2 minus 4 times 2 is 2 times 3 is 6. X power 3 upon 2 minus 1 is 1 upon 2 and 6 is there, and we have done it. So this is the way we can do the differentiation, the basic differentiation. In part M, what we have to do, because x is 2 times here, we can observe x is 2 times, x square and under root x. First of all, you have to make x squared like 2 and 1 upon 2, you have to add it first. And this x, you have to move up. Now, when you add this, is coming what? X 2, when we add it, is coming 5 upon 2 and minus, I just need to copy this first of all. Now apply the differentiation. When you apply the differentiation, this will become 4 multiplied by 5 upon 2 and 5 upon 2 minus 1. Simple differentiation you have to apply. 6 multiplied by minus 1 upon 2 and x power is minus 1 upon 2 and minus 1. Don't think this we have to use this formula here, because this is not positive 1 upon 2. This is minus 1 upon 2. Okay. Now I am going to simplify this. 2 and 4 cancel out is 2 times 5 is 10. X power 5 upon 2 minus 1 is 3 upon 2 minus cancel out this 3 and negative is positive. 3 x power minus half and minus 1 is minus 3 upon 2. We have to add it, and that's we have done. So this is the way we have done question number 1. So now we are doing question number 2. In question number 2, we have x in the denominator. We have to remove this first. How we can remove? Like in simple questions. Like when we are able to remove this x, how? 2x squared divided by x and plus 4x divided by x. We can write this x with both the numbers. X and x cancel out is coming 2x, and this is coming x cancel out only 4. Now we apply the differentiation. And when we apply the differentiation, there is no problem. It's very simple. Differentiation of 2x is only 2 and the differentiation of 4 is 0. So the right answer is only Q. Part B, again I have to do the same thing. Like I have to write x squared upon x minus 6x upon x and plus 4 upon x. When we simplify this, is coming x only and minus 6, and this will become x minus 1. Now apply the differentiation. Very simple differentiation we are doing. X differentiation is 1, 6 differentiation is 0, and when we apply here minus 1 will multiply with 4 is minus 4, and x will become minus 1 is minus 2. Even if you want to write this power like in denominator, you can write 4 upon x squared, and that's your result. Now, moving to part C, 4x cubed, like we just need to do the practice 5x and minus 3. I have to write 2x here, 2x here, and 2x here. What's the mistake here? Normally, students do this 2 also moved up. Now, don't move 2 with x. This is cancelled out, is coming 2 x power is 2 minus 2 x is cancelled is only 5 upon 2. And this situation, students, what students do, students also multiply like minus 1, just 2 up. No, this is a very common mistake. Please do not do. The 2 will remain there, only x will move up and minus 1. Now apply the differentiation. When we apply the differentiation, is coming 4x only power 1. This differentiation of constant term is 0. This minus 1 minus is coming plus 3 upon 2. And x power is positive 2 will be minus 2. Okay. Minus 1 is minus 2. If you want to give your answer like moving the power in denominator, you can move. This is the right answer. Like the same question part D is when we write x squared divided by 2x squared plus 4 upon 2x squared. Please don't move this 2. This will remain x squared squared cancel out. This 1 upon 2 left. This is 2 and 4 cancel out is only 2, and this is, you can shift this x squared up, this becoming minus 2. Now apply the differentiation. So this is the way we have to do the differentiation by making simple like the question. This 1 upon 2 is 0 because a constant term. This minus 2 is minus, plus 2 is minus 4, and x will become minus 3. If you want to write moving this power down is positive, and that's your result. In E part, what we are doing, this under root x means the power is 1 upon 2. This 3 x squared under root x, x upon under root x, and minus 1 upon under root x. I want to move all the under root x up. So this 2 minus 1 upon 2. This will become x1 minus 1 upon 2. And this will become x only minus 1 upon 2. Okay. When we simplify this, then 2 minus 1 upon 2 is coming. 2 times 2 is 4 minus 1 is 3 upon 2. Okay. When we do the difference, minus the fraction, this is coming. 1 minus half is half. So half means can we write only under root? Like can we write under root x? Because we know the differentiation of under root x is x. Okay. Now apply the differentiation. 3 power 3 upon 2. Multiply, when we multiply is coming 3 into 3 upon 2. X power 3 upon 2 minus 1. Then this differentiation is fixed. 1 upon 2 under root x. We don't need to like do the whole long calculation. This 1 upon 2 is plus 1 upon 2. And x power minus 1 upon 2 and minus 1. Now do the simple calculation. This coming 9 upon 2. X power is 1 upon 2. 3 upon 2 minus 1 is 1 upon 2. You can check. And then we have, this is we have done. I'm just copying this. And this we have to do 1 upon 2 is there. The x power is minus 3 upon 2. And if you want to make it positive, it's up to you. We have done it. In part F, what I think this is a similar question you can do, but you have to write like this. And simplify x power is 1 upon 2. Like x power is 1 upon 2, and you have to move this only x, not 2. And please do the calculation. So this way we have done question number 2. So in question number 3, we have like 2 brackets are given. So what we have to do in this question, first we need to multiply the brackets. X multiplied with 2x minus 1 and plus 1 multiplied with 2x minus 1. We have to multiply the brackets. This is coming 2x squared minus x plus 2x and minus 1. When we simplify this, is coming 2x squared plus x and minus 1. After doing the multiplication, now apply the differentiation. It's very simple. Now 2 is 4x, power is 1, this is 1, and this is 0, so we have done it. In B part, again we need to multiply. X power is 1 and 1 upon 2. Then when you multiply, the power will be added. So that's That's the way this we are doing here. So 1 plus 1 upon 2 is 3 upon 2. Now after getting the result, after the multiplication, we have to apply the differentiation. It's coming 3 upon 2 coefficient 3 upon 2 minus 1. You can do the direct calculation, there is no problem. But to like explain each and everything, I'm just doing all the calculations. 2 is 1 upon 2 and minus 2, and that's we have done. In this part C, what we have to do, like both the brackets are same, the sign of only sign is different, so we have to use the formula a squared minus b squared. Remember difference of two square formula. So 1 minus, sorry, x. Now apply the differentiation. When we apply the differentiation, the constant term is 0 and minus x is 1, so right answer is minus 1. That's we have done. So this is the way. I think so. Question number 3, the other parts you try yourself. I'm moving to question number 4. Now moving to question number 4, this type of questions are a little bit important. Like in A part, question number 4, part A, what we're doing, find the value of f dash, f prime, x at the given value of x. This type of questions are very important. What we have to do, I'm just writing here one thing. When we have like y is equals to 2x squared plus 3x minus 1, and I want to do the differentiation, so I will write d upon dx here in left hand side and d upon dx here in right hand side, and I will apply the differentiation. This y will become y dash. This y dash means this is d upon dx involved, right? And the answer will be 4x plus 3. So such a way, like whenever we have f of x is equals to 3x squared plus 2x, and when we apply the differentiation, when I write here, like suppose d upon dx and d upon dx, so this d upon dx will make fx as f dash x. So whenever you have f dash or the f prime, we say f prime or f dash, that means we apply the differentiation 6x plus 2. So now what we are doing here, we need f prime, we need to find f prime, f dash. So what we do, when we write d upon dx, do you want to write d upon dx before fx or just f dash? When write f dash, it means I have to apply differentiation in right hand side. Okay, I'm just writing this 2x squared minus 2x and minus 4. Okay, f dash is applied and I want to do the differentiation. This is coming 6x minus 2, and after doing this, we have done the differentiation, but we need to find the differentiation at point x is 2. Now I will apply here x is equal to 2. So what's the result? This will become f dash bracket. I'm writing here what? I'm writing here 2. Then I have to apply also 2 in right hand side where we have the position of x. We need to substitute. Now simple. I want to do 6 times 2 is 12 minus 2, and the answer is coming 10. So this is the way we have done that the f dash of 2 is coming 10. This is the way. It's very simple. Now again same thing when I want to do question number B, part B, what I need, I will just write directly f dash. F dash means I have to apply the differentiation right hand side. 6x, I'm writing here d upon dx. I'm not applying first, I'm just writing. This x will become minus 1. Okay, after do not put the value here first. I have to apply. What is the result? 6x is 6, minus is plus, power will multiply with coefficient, and x will become minus 1 is minus 1 is minus 2. So when we get the final answer by moving this x negative down, now, can you put the value x is minus 1? Minus 1. This is the way like we have done minus 1 whole square. 6 plus minus 1 is positive 1, 3, and answer is coming 9. We have done it. So this is the way when we do the differentiation, when is given f dash something, f prime something, it means we are doing the differentiation. Moving to the next part. Next part is same, like we have the questions. Question number C. Again, what we need to do, we have to apply f dash. F dash means we have to do the differentiation. 3x differentiation is 3, and minus 4 is minus 4. X differentiation, remember under root x what? 1 upon 2 under root x. So I'm writing 1 upon 2 under root x, and we have done it. You can do it directly when you applied f dash. So f dash is coming 4. I'm writing this 2 and 4 cancel out, is coming to 2 upon under root 4. 2 upon 2, and answer is coming 3 minus 1 is 2, and that's the result. Remember, when in the question, when under root x is already given and you apply 4, the answer is always positive 2, not plus minus 2. Remember, when root is already given in the question, we write always positive. This situation, we have to multiply like both the brackets. When we multiply, it's coming x squared and minus plus 3x, minus 4x, and minus 12. And finally, this result is coming minus x and minus 12. Now, this is not, we just multiply. This is fx. Now, apply the differentiation. When I write f dash, I will write this will become 2x minus a minus 1. Differentiation of x is minus 1, and this is 0. Now, apply 3, and that's your 6 minus 1 is 5, and that's we have done it. This was question number 4. So by this way, we have done question number 1 till question number 4, exercise 15.1. If you think this video is useful for you, please subscribe my channel and wait for the next video because I'm moving to question number 5 onward. Thank you so much and have a nice day.